All right, so I'm going to try to talk about deep learning and Keras in 10 minutes. So that should be fun. So yeah, the title is Deep Learning Made Easy, kind of, I guess. I say kind of, I guess, because I'm not an expert and I don't really use deep learning in production, but at Domino Data Lab, I'm constantly talking to folks and they're always like, oh, talk to me about deep learning. So I've had to learn a little bit about it, and actually in October was the month of deep learning for Zillard and I, where we tried to learn about deep learning. So here we go. So this is me. All y'all know me at this point. Those are my 3 fabulous dogs. That's my beautiful wife. I've been a programmer for a fantastically long time, and I've also put together this slide recently. I didn't realize I've been doing like HPC and data science-y stuff since like the mid-90s. It's one of those things where like time flies really, really, really quickly. I hired my first ML engineer in 1999, specifically Anatoly Gorchechnikov, who now has his PhD in neurocomputing from Boston University, because I was convinced that if you took buying data from users and you ran it through a neural network, you could predict buying patterns and upsell opportunities. In 1999, I was right. I made $0.00 off of it. It was, oh no, don't do this to me, computer. Thank you. So, but here we are. So what am I going to talk about in my remaining 8.5 minutes? I'm going to try to tell you a little bit about what deep learning is. I believe all of y'all probably already know, but I needed to pad it out a bit. I'm going to do a quick tour of Keras, and then I'm going to show you just 1 or 2 examples. To be very honest, I wanted to have more examples, but Tempus fugit. So what is deep learning? Why do you care? Why does it suddenly matter? I think this is probably the most important slide I'll show today, which is... oh, it's going to be one of those days, everybody. Hang on tight. So this is the most important slide. This is Andrew Ng's slide. It is the slide that has caused the most arguments between Zillard and I on Slack. It is his claim that as the amount of data increases exponentially, the performance of deep learning neural networks is going to outperform most machine learning algorithms. This is a slide that he has shown at the Bay Area Deep Learning Meetup. Okay, that's going to get annoying. Give me a second. Let me see if I've got an issue with my screen. It's good that I'm the one doing this so we can get this out of the way. Desktop and screensaver. So now start after 20 minutes. All right. It keeps blacking out, so let's see what, actually, you know what I'm going to do is I'm going to turn it on to sorry everybody, this is a community meetup. All right, so the idea is that deep learning is going to outperform all other machine learning algorithms. It's one of those things where when you actually pin Andrew Ng down and you actually ask him, it's like, hey, what is the situation? He goes, well, you know, that's our theory is that eventually it'll do that. So what is deep learning? Everybody here has at least heard of a neural network. That's what I'm working under the assumption. The assumption is that it's a bio-inspired model where you have input neurons that take some input from the world. They pass them through some activation function. Sigmoid is the most common one historically, but there's been a lot of work with like ReLU and tanh functions. And what basically you're doing is it's a universal function approximator. So that's a standard neural network or a multi-layer perceptron. A deep learning neural network is the idea that you take these layers of neurons and you just add layers and you make them really, really deep. That's what everybody says a deep learning neural network is. They're like, oh, it's just a multi-layer perceptron that's been made deeper. So that's not true. It's kind of a lie. Deep learning is kind of this marketing term for a series of tips and techniques and tricks and different kinds of architectures and voodoo, lots and lots of voodoo. Yeah, it's true, because like if you look at a deep learning network that is for like natural language recognition and you look at one that is for like ImageNet, like the only thing that they have in common is they're really deep and that they take a lot of time to train. Like other than that, there's like not a lot that is common between them. So should you care? Like why do you care? So you care if you want to make a bunch of money because these deep learning people are getting paid a lot of money, but you care if you have unstructured data. You care if you have images that you want to do something smart with it. You care if you have sound that you want to do something smart with it. You care if you have text and you want to do something smart with it. That is when you really, really care. If you've applied traditional machine learning approaches and those approaches have basically plateaued out, that's when you want to like look to deep learning. But these are 2 quotes from 2 pretty well-respected data scientists, and they kind of just, when in doubt, use XGBoost. That's the #1 ranked data scientist on Kaggle, right? So it's one of those things, there's a bunch of hype, and Zillard will be giving a way better talk about this next year. But unless you have really tapped out traditional machine learning, don't spend your time on deep learning. that being said, hey, let's learn about deep learning. So a quick tour of Keras. So Keras is a really, really nice API. Like when it comes to machine learning APIs, there are some that are fantastic and there are some that are utter trash. This one is really kind of nice. There's not a lot of weirdo stuff you have to do. Like the actual theoretical model that you build in your head when you're building a deep learning network and the actual code, it actually kind of looks like the pseudocode that you would write in order to actually write the deep learning network. The smart thing that it does is that it doesn't handle any of its own processing. Like they didn't do the job of creating a beautiful API and also handling all the weird hard math. What it does is it compiles to 2 different backends right now. It compiles to either TensorFlow or Tiano. And the focus, and they say right on their docs, is the focus on enabling fast experimentation. So the question everybody then asks is why don't I just use TensorFlow or Tiano? The answer is that if you look at them, so if you look at the docs for Keras, it's like, we are a tool for fast, deep learning, like getting your work done. If you look at TensorFlow or Tiano, they're like, we're an open source graph, data flow, numerical computing soup. And unless that's what you want to do, those APIs are way, way, way too low level. You're going to be doing, basically, they're linear algebra libraries. So unless what you're trying to do is invent an entirely new type of layer or an entire new activation function or something like that, it's the wrong abstraction layer. You want to go one abstraction layer higher, and again, you want to use the right tool for the right job, right? And if you're doing deep learning for the purposes of data science, you don't want to be playing at the linear algebra library level. You want to be playing at the modeling layer. And Keras is a modeling API. So Keras is all about layers. What you basically do, the highest level abstraction is a layer, and everything is a layer in Keras. And I'll actually talk about some of the basic ones. And the neat thing about this is that it provides very modular deep learning networks. And what it allows you to do, which is the thing I love to do, is it allows you to see either papers on arXiv or networks that other people have talked about, and it allows you to steal their ideas and implement them yourself really, really easily because you're working with these really nice building blocks. Yeah, it's not Legos, right? Like if you're using TensorFlow Tiano, you're working with like the entire program for, this is the Pima Indians Diabetes data set. It's like a UCI canonical data set. And like this is it, like literally this is the modeling step over here. Like make a model, add an input layer, add a middle layer, add an output layer, compile the model, fit it. That's it. You don't have to do any other magic. Like this is something that like way back in the ancient times there was a lot of work to get this done. And like notice like the activations are just parameters you pass. It's all just really, really nice. It has, we won't get into FX and batch sizes and all that, but it's all a really clean API. So this, for example, is to get near human performance on CIFR10. This is just a model. But again, you see it's the same idea, right? You create a sequential model. You're adding activation, convolutions, dropouts. You're adding all these layers. You're stacking them together. At the end, you hit model.compile, and whatever backend it is that you have, either TensorFlow or Tiano, it'll actually compile it to that. This can be a lengthy process because like it's compiling, right? Like that takes a while. But at the end of that, you've got a compiled deep learning network that is compiled for your specific architecture. This one gets you 99.25% test accuracy on MNIST, which is like near state of the art, and it like fits on this slide in a font. And I actually have a question. Can y'all in the back actually read that? Yeah, so think about that, like near state-of-the-art performance on the MNIST data set on a font that you can read all the way in the back of the room. Like that's pretty remarkable to me. If y'all are interested in actually like playing around with this code on GPUs or something like that, send me an email. I can hook you up with a project that's already got everything configured. I didn't get into that, but like that's where the sausage is made, like actually configuring it and holding your mouth right for CUDA to like work and not blowing up your laptop is kind of a pain. Just send me an email and we can talk about it. All right, so that's my talk. Thank you. I hope you learned anything at all. And yeah, let's get on with the show.